Welcome and thank you so much for attending our first hands-on webinar of the Tracing Epiverse series. My name is Diana Fajardo Pulido. I am the community manager of data.org and also the Epiverse initiative. Today we will dive into Epiverse's practicality and interoperability with two of our powerful tools, Clean Epi and Simulis, and we will see how they work, how we can use that in our practice in public health, epidemiology, data science, and so forth. Before we will start, I would like I'm going to share my screen and show you some miscellaneous for everyone. So I just wanted to share with you that as a community, we are dedicating to providing a harassment-free, inclusive, and welcoming environment for all participants, regardless of gender identity or expression, age, sexuality, orientation, disability, physical appearance, body size, race, ethnicity, nationality, religion, socioeconomic status, or education level. We prioritize the safety and well-being of marginalized individuals and communities over the comfort of those in positions of privilege. And maintaining the integrity and inclusiveness of our community is a shared responsibility between all the people present in this webinar. So this hands-on webinar is being recorded, and if you don't want to and it will be shared along with the presentation slides by email. If you have issues sharing your identity in the recording, please change your name or your photo, and due to the number of participants, your microphones have been disabled. All messages from the speakers and links to resources will be shared in the chat. Please let us know if it's working. And also please use the Q&A function located in the toolbar to post your questions. Without any further delay, I will welcome our speakers. Joshua Lambert, Karim Mane, and Andrew Valle-Campos. Joshua is, I'm sorry. So Joshua is a research software engineer at the London School of Hygiene and Tropical Medicine. He works for the Epiverse Trace initiative. His background is in evolutionary biology, and currently his work focuses on co-developing a suite of R packages for outbreak response and pandemic preparedness. Welcome, Joshua, and thank you for joining us to this webinar. Karim is a research software engineer at the Medical Research Council Unit in the Gambia, which is an allied of the London School of Hygiene and Tropical Medicine, and he's also working for the Epiverse Trace initiative. His background is in bioinformatics, and he's the maintainer of Treat Epi and Clean Epi, two of the tools of our Epiverse community. And then we have Andre Valle-Campos, who is an RSE, and he's also the training lead of Epiverse, and he will be supporting us with the interactive platform for you to get the hands-on the code for Clean Epi and Simulis. So Joshua, over to you.
Thank you very much, Diana. I'll just share my screen. Hopefully you can all see my screen. So thank you very much, everyone, for joining for today's showcase. It's very exciting to be able to share some of the work we've been doing in Epiverse Trace. So as Diana said, I'm Josh. I work at the London School of Hygiene and Tropical Medicine, based in the Epiverse Trace initiative. And today I'm going to be talking about the Simulist R package, so an R package for simulating outbreak data. But first off, I just want to take a step back and maybe for those that are a bit more unfamiliar with Epiverse, what is it and where does Simulist fit in? So Epiverse is an ecosystem of R packages. And the way we sort of structure this is we go from early tasks through to middle tasks through to late tasks. So this is sort of early in an outbreak, in the midst of an outbreak, and then later on in an outbreak. And we offer our packages on a whole range of things from reading in and cleaning data, simulating data, reading and using epidemiological parameters, through to calculating case severity risks and force of infection, through to estimating individual level transmission variation and super spreading, right through to sort of compartmental and scenario modeling and vaccine efficacy. So I just wanted to sort of set the scene for where we are with Epiverse and where Simulist fits into the bigger picture. So Simulist in particular is an R package for easily simulating individual level outbreak data. And with this package, we target two particular common types of outbreak data, which are line lists and contact tracing data. And when we came to develop Simulist, it was really quite a surprise that there wasn't an R package that was well maintained, documented, tested, that would do very simple things around simulating outbreak data. So given this was sort of an open goal or an open niche, we thought it would be good as part of the Epiverse initiative to develop something that filled this. So what were the sort of tenets we had when developing this? So we wanted it to simulate epidemiologically realistic outbreak data, and that's really important. And it should be really highly customizable for users. So you should be able to sort of modulate or augment the epidemiological or demographic dynamics of the outbreak of the simulation. So the scope of the package is mainly primarily designed for teaching and method testing. So you really see this as a pandemic preparedness tool and not a sort of a real-time outbreak tool. So it's really for training people working in public health and learning and being taught epidemiology before outbreak scenarios that they're potentially going to be working in, and also methods testing. So methods that may estimate transmissibility or severity of an outbreak you can test with Simulist because you know sort of the simulation or the generating process and all the parameters that were used to generate the data. We also thought it was really important for it to be interoperable with the whole EPI ecosystem of R packages. So there exists a large array of R packages out there for epidemiological tasks and outbreak analytics. And we really wanted to fit in Simulist with all of those that offer really great functionality. And lastly, we wanted to complement the Outbreaks R package. So some of you may be aware that Outbreaks is an R package that contains empirical outbreak data sets. So if you wanted, empirical data, there's Outbreaks, but if you wanted theoretical or simulated data, we really wanted Simulist to fill that niche. So what are the main features of Simulist and the simulations that it offers? So we wanted it to be parameterized with epidemiological delay distributions, and these are customizable to the user to sort of customize how you want the outbreak to transfer, so onset to hospitalization, onset to death delays, etc. We offer population-wide or age-stratified hospitalization and death risks. So this could be the case if, for example, the mortality risk for a pathogen is much higher for older people or younger people in the population. You can have age-stratified risks. We also have uniform or age-structured populations as an option. So this is the case whereby you may have a very young population or a very old demographic. You can think of contrasting places like Japan to say like Nigeria, and we allow that customization of the model to have age structure in the populations. We have constant or time varying case fatality risk. Again, this is a very high level, sort of broad. This is not a mechanistic model, so we don't explicitly model things like vaccination, but you could model something like that where you could have time varying case fatality risk that declines over time. And I'll get a little bit more into that later in the talk. And then you can have customizable probability of case types or contact tracing follow-up. So that's the simulation features. Moving on to some post-processing. So once you've simulated your data, you can then snapshot that in real time, which will account also for right truncation. If you want to test methods that, for example, work on real-time outbreak data, or you can make data messy. So the data by default that's produced by our simulation functions is in a sense ideal or perfect or complete. And we know that in real life, in sort of empirical scenarios and outbreak scenarios, that's not the case. There are often inconsistencies, mistakes, and missing values in data. So we offer that by messing sort of the data up. So we hope it's a relatively simple package interface. We offer 3 simulation functions. So sim line list will produce a line list, sim contacts for contact tracing data, and sim outbreak for if you want to produce a line list and contact tracing data from the same outbreak. We then have the post-processing functions, as I mentioned, so truncate line list for real-time outbreak snapshotting, and messy line list for introducing those mistakes and those inconsistencies that I mentioned. Lastly, we have a helper function, create config. I won't go into the details of this for this talk. That's just basically for the simulation functions that take a config list. If you want to get into some of the more advanced features, you'll have to start using this. So we have a helper function to do that. But like I say, for the purpose of this talk, it's not super important. So just before I move on to the sort of details of the functionality, I just want to give a broad overview of what the simulation model is. So fundamentally, Simulist and the simulation functions in the package are essentially a branching process. So in our case, it's a network adjusted branching process, but the details that are not important for this talk. Essentially, you start with a single index case and you sample the number of contacts from that case. So as shown here, inset into this figure, you have number of cases, which is distributed by some distribution. So it could be Poisson negative binomial. It takes an arbitrary distribution. From that, you sample, in this case, the index case has 3 cases. So that's the 3 dots below with arrows pointing to them. And of those 3 contacts, you have 2 cases. So cases being orange and contacts being sort of the light blue color. And this continues. So you start with a single, you see the outbreak with a single case, and then by default, Simulist will simulate an outbreak until it goes extinct, until there's no more cases. Yeah, so that's sort of the basic fundamentals of the simulation model. So getting started with the package, we hope that we've made this sort of as simple as possible. So all of the functions have sensible default arguments, so you can get started without having to specify any of the parameters. So you can see in the example I have here, I just simply set a seed so that to ensure the output is reproducible. And then I just call this function sim line list from the simlist package, and I just assign this to the line list variable, and then I show this a snapshot of what you get output. So here you get the standard structure of what comes out, the line list that comes out of sim line list. You have an ID column, case names, case type, the sex, age, date of symptom onset, date of reporting, date of hospital admission, the outcome type, and then the date associated with that outcome, the date of first contact, the date of last contact, and then a CT value. So the CT value is only for confirmed cases. So we assume in these cases, these are sort of PCR positives, and you'd have a CT value for those cases. So that's just to give an overview of what the sort of simple line list you'd get by default. If you didn't really care about the sort of epidemiological characteristics of the outbreak, you could call this function and you'd get your sort of your default line list. Moving on to contact tracing data. Again, we try and set this up to be as simple as possible for starting out. So here I've just called the sim contacts function using all of the defaults that are provided by the function. And you can see here you get the standard structure of the contact tracing data. So you get the contact who it's from and who it's to, the age of the contact, the sex of the contact, the date of first contact and last contact, were they a case or not, so whether that person was infected, and then the status, whether they're under follow-up, lost to follow-up, or whether they were a case, in which case this was case will be yes. So you can start to see how from very early on, you can start to create these data sets very easily, hopefully, just by calling a single function. And if you don't really care about the characteristics of the data, you don't even have to specify any of the arguments. So to demonstrate some of the more sort of some more functions or the more features, sorry, of these functions, custom epidemiological delay distributions. So here now I'm again calling the sim line list function, but this time I'm specifying the arguments with custom distributions. So here I have the first 5 arguments of the sim line list function. So that's contact distribution, infectious period, probability of infection upon contact, onset to hospital admission, and onset to death. And here you can see that the way it's set up is it's very flexible to allow arbitrary distributions. So in this case, we've specified the contact distribution is a negative binomial with an average of 2 contacts per person and some level of dispersion. So in this case, it's 0.5, so you may get some over dispersion, potentially some super spreading in the outbreak. You have the infectious period for each case. In this case, it's gamma distributed with some parameters. The probability of infection is 50%, so on average, 50% of contacts will become cases. Onset to hospitalization is log normally distributed with these parameters, and then onset to death, the same here, but with a Weibull distribution. So hopefully what I'm doing with this example is just showing how flexible the framework is to really have custom epidemiological parameters and customize the epidemiological outbreak characteristics. Moving on to controlling the outbreak size, we have the outbreak size argument, which is a vector of 2 elements. So here, I again simulate a line list, but this time I'm saying I want my outbreak to be between 100 and 500 cases. And if I set the C to 1 and I run this, I can see that I get 158 cases. Here, for the purpose of illustration, I set the seed to something else and simulate again. And you can see in this case, I get a warning saying returning data early with 534 cases and 1006 total contacts. And the reason for showing this is the first element of the outbreak size vector is a hard lower bound. So you will always get an outbreak with at least 100 cases. But the second element is a soft upper bound. So you may exceed this by some level. So by default, Simulist will simulate an outbreak from start to end. So from the first case to extinction. But if you exceed the upper outbreak size, it will stop at that next generation. So in this case, it's got to 500 cases, in this case, 534, and then it stopped the outbreak. So in this case, when you look at the outbreak, it may not go to extinction, it may stop sort of abruptly. Another feature which may be common if you're working with anonymized data is by default, we have case names that are generated, sort of ethnically diverse name generation. So by default, anonymize in sim line list is false, in which case I've just focused on the two columns of the line list here, ID and case name, and you can see you get a range of case names. However, if you would, for whatever reason, want to anonymize this data, you just specify anonymize equals true, and then you get a unique ID hash for each name instead of the name. In this case, it's not super important, given it's simulated data, there's no real people involved, but just in case you want to sort of mimic that anonymization process, you can do with Simulist. Again, the same thing with case type. It's really flexible for users to modify. So here we use sim line list. Again, I'm focusing now on the ID and the case type columns. And you can see by default, I get a range of suspected, confirmed, and probable cases. So by default, I think it's 20% are suspected, 30% are probable, and 50% are confirmed. But for example, if you have an outbreak with, for example, a very different surveillance system that you want to simulate, you might say in that case, well, I want, if you're doing a lot of PCR testing, you might say, well, 90% of my cases can be confirmed and only 5% will be suspected and 5% will be probable. And simulating with this, and again, just showcasing the ID and the case type, you can see in this case, you get all of the confirmed case for the first 6 cases shown in the line list. So that's just to show how you can modify these very flexibly by specifying your own numbers here to give your own probabilities of case types. So outbreak snapshotting with truncation. So this now brings in both the simulation functionality with the post-processing. So here I'm going to simulate a line list, but this time I'm specifying a reporting delay. So by default, the date of reporting column in a line list will be identical to the date of symptom onset, so this date onset column. However, when specifying a reporting delay, here we specify it as a log normal distribution, you can see that there's a difference. So in this case, there's a 4-day delay between symptom onset and date of reporting for the first row. The second row, there's a 1-day delay, and then for the third row, there's a 10-day delay. So in this example, what we're saying is reporting is happening after symptom onset. And if we want to mimic a real-time snapshot whereby you want to say, oh, well, the outbreak didn't end, we're in the midst of the outbreak, we can modify the data to do that. So here we have the simulated data that I just simulated. I've plotted it by week. So here it starts in 2023 Epi week 1. And I want to assume that instead of the outbreak ending as it does after week 6, I want to say we're in week 5. So what does that data look like? And we can do that with the snapshotting. So here I call the truncate line list function. I specify the line list and I say I want to truncate this, in this case in week 5, which is the 1st of February 2023, and that returns a truncated line list. So what that will do is that will say any cases reported after that date are removed from the line list, and any events, so any cases that are reported but have events after that date, for example, it could have symptom onset and reporting, but not yet be hospitalized or have an outcome, those will be set to NA. So you're giving that sort of effect of real-time outbreak data where you don't know all of the events because things are still in progress. And again, I just show this for the difference. So if I go back to the previous slide, you can see I have the full outbreak and a snapshot date. And then to move forward after the truncation, you can see how we now end on week 5 and the number of cases in that week is yet to be fully resolved because of that right truncation effect. So some more advanced features that I'm not going to cover in this talk just because of time, which we have vignettes for. So the slides will be shared after the webinar, and each of these link directly to the vignettes that describe them. And if you want to look at all the vignettes, we have the link here at the bottom that will take you to the Simulist website, and you can view all of the vignettes on there. So some of the more advanced features we offer are age-stratified hospitalization and death risk, age-structured populations, time-varying case fatality risk, and then reporting delays and right truncation, which I've just briefly gone into a little bit just now. So touching on interoperability of the package with the ecosystem. So complementary R packages with Simulist are, the selection of them are Epiparameter epi contacts, incidents to, and clean epi. So Simulist and Epiparameter. So if you're not aware, Epiparameter is a package that stores and it helps working, is a helper package for working with epidemiological parameters, epidemiological delay distributions. And Simulist works really well with that because it recognizes objects that come from Epiparameter and reads them and accepts them as input. So here we create an Epiparameter object for the infectious period. In this case, we create it for COVID-19, although it's not a real COVID-19 infectious period. And we say the infectious period is distributed with a gamma distribution with these parameters. And for the onset to death distribution, we actually have that for COVID-19 in the epiparameter database, so we can read that directly. And then we can very simply pass these into Simulist, into the SimLineList function, and it will recognize that these are epiparameter objects, handle them appropriately, and then use them. So if you don't want to specify them all, if you don't want to customize them yourself by specifying them as I did earlier, you can read them either from the epiparameter database or you can create epiparameter objects yourself, as shown above. Simulist and incidents too. So the plotting that I showed on previous slides is also using incidents too. So this is for aggregating line list data to incidents data and then very nicely plotting it using a very few lines of code. So here the example, I simulate a line list again using the very simple defaults that are available. I then aggregate this using the incidents function from the incidents2 package. I say I want to aggregate by date of symptom onset and that interval of aggregation to be daily. And then I simply create that object and plot it, and I get a very simple epi curve here, showing in this case an initial rise in cases, and then a sort of relatively spiky outbreak that sort of sputters along until it goes extinct. We can do more complex things. So I won't go into the code in much detail here because it's a little bit more complicated. But essentially, again, the process is very similar. We are simulating a line list. In this case, you're doing some rearrangement with dplyr and tidyr to make sure it can be plotted. Again, you're making an incidence object, but this time you're saying, I want the incidence of symptom onset, hospitalization, and deaths, again, daily, and that to be plotted. And again, in very few lines of code, you can get a nice plot with incidence of case onset, case hospitalization, and case deaths over time throughout your outbreak. Another interoperable package is EpiContacts. So here again, we're simulating an outbreak. So here we call the sim_outbreak function because we want both a line list and contacts data. We pass those into the EpiContacts function, make EpiContacts, and we just specify some information like the ID of where the case name is, where it's coming from, the person it's coming from, so the contact, and then who they're contacting, so to, and whether it's a directed graph, so we know that the transmission process is directed because you pass from the infector to the infectee. And then we can very easily plot this using plot EpiContacts. And what's nice about EpiContacts is you get this really nice interactive plot. So here you can see that I can interact with this, I can move it around, I can zoom in, although the zoom is very sensitive, so I'll try, there we go. Yeah, so you can see it has the case names. If I hover over it, I can click on it and see the information. So here we have a case person aged 11 with their date of onset, date of reporting, and so on. And we can zoom out if if it works. There we go. We can, for example, have this drop down. We can select by ID. So here we select Edward. We show where that is in the network. So here we show who Edward was contacting with and whether it was a transmission event or not. So this is a very nice piece of functionality that we really want to integrate with by easily simulating data, plugging it into EpiContacts, and then producing this really nice, this plotting functionality that you get through the EpiContacts package. And lastly, Simulist and Clean Epi. So also the purpose of this showcase is to showcase some of this interoperability between these two packages. So again, we're doing a very simple process of simulating line list data. And then this time we're using the post-processing function messy line list. So in this case, again, there's a lot of defaults. So you don't need to specify anything. If you just want sort of the default messiness, default inconsistencies, you can just pass in the line list here, and that will do that. You can also customize it with more arguments if you want to. You can look at the help documentation for that. So for example, at the bottom I've said here, if you type into the R console question mark and then messy line list, this will bring up the help page and you can see all the different options for introducing inconsistencies and so on. So just to highlight some of these, you can see that in the ID column, you have numbers and words. You also have missing data in the form of NA. You have inconsistently recorded sex. So here you have the single letter F, here the full word male, and here the single letter M with different lowercase and capitals. And then you have a range of different things here, some examples being missingness, so NAs throughout the line list. And that works really nicely then with Clean Epi, which Kareem will talk more about. So here I give a very simple example of where you have that messy line list and you pass that into some cleanepi functions. For example, here, convert to numeric. So I say that I want all of my columns, ID and age, to be numeric, and cleanepi can then recognize which ones are words of numbers, and then convert them into their numeric characters. It can also remove duplicates. So for example, if I go to the previous slide, you can see here this James Jack case is an identical case that's mistakenly been entered into the line list twice. We of course want to remove that. So cleanepi can very nicely do that with the remove duplicates. But I'll leave more of that to Kareem's talk as he goes into it in much more detail. So that brings to a conclusion the overview of the Simulist package. So hopefully that was it was a relatively quick run through, but hopefully that was quite clear on what Simulist offers, both in terms of scope and in terms of the functionality and how to achieve that. So just lastly to say, if you have any feature requests or bug reports, if you're using the package, please do log these on our GitHub. So open issues, requesting things. If you're not using GitHub, feel free to reach out to us via email, requesting things, or just discussing the package. We're always more than welcome to discuss the work we're doing. And contributions are also welcome. So if you'd like to help develop this package, we're hoping that Epiverse is a community initiative. So if you'd like to engage and contribute to either Simulist or other Epiverse packages, contributions are also more than welcome. So yeah, with that, thanks for listening. I'm happy to take a couple of questions before moving on. And as I do, I'll pass over to Andre to share for the next interactive session on Posit Cloud. So while he's doing that, please do put in the Q&A box if you have any questions. So one question coming through from Patrick saying, can you customize the contact matrix used to generate the data? So what Simulist uses is not a contact matrix, but rather a contact distribution. So that was the sort of Poisson distribution or negative binomial distribution or any sort of arbitrary distribution that you specify. So it's not a matrix. So the customization comes in rather how many contacts does each person have and how are they distributed. So if you wanted it to be very equal or very homogeneous in the population, you could have a simple Poisson distribution, or if you wanted to have more extreme events where you'd induce more super spreading, for example, you could have like a negative binomial and set the dispersion parameter to be very low, and that would let you do that. So follow up. So you can stratify the question again for Patrick. You can stratify the distributions to use different distributions or distribution parameters. Yes. So in terms of customizing the distributions, they're fully customizable. So as I showed with both with using simple R functions or using epiparameter objects, you can specify them freely. So the only requirements are the contact distribution has to be a discrete distribution, so Poisson negative binomial or others, and the infectious period, and then onset to events, so onset to hospitalization, onset to death, etc., have to be continuous distributions. So they were log normal, gamma, etc. But other than those two requirements, it's really flexible to be customized however you wish. Another question coming in, can Simulist be used for mortality data? So just purely monitoring deaths for certain causes or syndromes or symptoms over time. Um, So we don't generate that by default. So we don't offer functionality to directly simulate monitoring deaths. But you could, for example, do some data manipulation on a line list, I'm guessing to, I'm not sure exactly what you mean by sort of purely death data, but for example, you do have, as I've shown in one of the plots, deaths over time. So you have the incidence of deaths, or you can have that if you choose. So that, for example, could monitor it. There's no mechanism of causes or syndromes in the simulation. It's quite simplistic in that respect. Um, Kind of the theory being that it's sort of one pathogen, sort of potentially could be like a zoonotic spillover, goes into one person and then spreads from there, sort of early early outbreak dynamics. So we don't really explicitly model multiple causes or syndromes. I'm guessing that would be more of a post-processing you would do once you have a line list from Simulist. You could then probably map onto that syndromes if you wanted to. But again, please do, like I say, get in touch either on GitHub or via email if this is something you think the package could extend to be. If you think there's useful functionality there that it currently doesn't do that would be useful for you, yeah, please do let us know. Just while I'm answering questions, Andre, are you able to share your screen with the showcase link so people can also start to get over to Posit Cloud?
Sure.
Thanks. So we have another question coming in from Win. So could this package calculate necessary epidemiological parameters in outbreak like R naught? So there is no inference in Simulist. So we only simulate data. And as shown by the way it's parameterized, we don't use the reproduction number to simulate to simulate the data. So I'm just going to quickly pause answering this and then hand over to Andre, just so he can introduce Posit Cloud, so everyone can get moving over there. So just to briefly introduce, we're going to have an interactive session now for the next sort of, I don't know, Andre, 10 or so minutes. And that will give, there's scripts on the Posit Cloud. So if anyone hasn't used, Andre will introduce what Posit Cloud is. And that will give you a chance to play around with Simulist and some of the functionality that I've just been describing. So yeah, over to you, Andre.
Yeah, thank you, Josh. Yeah, essentially we're going to access to an RStudio session that has all the packages that we're going to be showcasing today online on the web. So I just paste this link in the chat for you to access on your computer. This is going to be more accessible or easy to use on your computer. So if you access this link, you should get access to this type of platform. You possibly would need to create an account on Posit Cloud. I usually choose to link Google with this, which makes this like faster. And then we expect you to get access to something like this in the right. You're going to have like a loading bar with a deploying project, which is the environment that we set up for this. And if you manage to fulfill these 3 steps, then we suggest you to create a safe, a permanent copy of this that you are going to find here in the top right corner of your monitor. So if you can follow us, let us know. If you have any issue, let us know also in the chat. But here you can keep making your questions if you start having some more questions, but you can also access this link to start interacting with the code. What we expect at the end is that if you follow these 3 steps, you then arrive to something like this. So you are going to have access to this RStudio session that here it says Epi Showcase. You can access to different scripts. For example, to start practicing Simulist, you can access to link number 1. Here I'm going to just highlight my now I think that you can see where I am with a red dot. So here in the bottom left, bottom right panel of RStudio, you're going to see a set of links, and you're going to find number 1 Simulist with some sample code that Josh showed. So I think that we can, Josh, if you wish, you can keep answering some questions while people is interacting with the code and find more questions to ask.
Yeah, perfect. Thank you for that, Andre. Yeah, so if anyone has any issues getting onto Posit Cloud, please do post in the chat or in the Q&A. We can hopefully get through any of those issues and get everyone, get everyone on there. So like Andre said, just have a look through the Simulist script that's on there. It has a load of the code plus more from the presentation. So just have a play around, sort of get familiar. So to go back to that question that I was partway through, so I'll just repeat the question. Could this package calculate necessary epidemiological parameters in an outbreak like R naught? So we don't do any inference, we don't do any estimation in Simulist. It's purely a simulation package. And the way we set up the simulation is not using R0. We in theory could, but instead we use a contact distribution and a probability of infection. So if you think about it like on average, you have 2 contacts and on average 50% of them get infected. That roughly is equivalent to an R0 of 1, right? So you have 2 contacts and one of them gets infected, your effective reproduction number in that outbreak is roughly 1. It's not exactly the same. So I guess where Simulist we hope is really useful is in testing packages that do estimate necessary epidemiological parameters in an outbreak. So you've got the likes of EpiNow2, EpiEstim for transmissibility, EpiNowcast. You could do severity with the likes of with EpiNow2 or with the CFR package in Epiverse. So where Simulist we hope provides a lot of utility is in simulating data where you know these parameters. R0's a little bit harder to get an exact number for, but for example, the severity, you can directly encode what the severity should be for a pathogen, and then you can check that your inference method is correctly picking up and estimating that number. So hopefully that answered the question. There's one question in the chat, which I think I'll pass over to Andre. Andre, there's a question here on learning R. So I think that's given your role as a teaching fellow, would you like to take that one?
I would love to answer. However, I can't see the Q&A. I don't know why. So if you can help me with that.
I mean, I can read you the question if you want,
Yeah.
and you can have a good answer, and then we can also write on later. So, question from Siba. Apologies for that mispronunciation. Writing from Guinea in West Africa. I'm a medical doctor and have been dreaming how to deeply learn R as I have a basic level. I would like to take a private course. Are there opportunities? So maybe you could mention some of the Epiverse opportunities that we offer for training.
Yeah, sure. So we have an upcoming online training on July. It's going to be a short course from the London School. And I think we still have open applications through this month. And we're already past the moment for accessing to scholarships, but this course seems to be opening. We want to make this course opening like frequently also in coming months. So just stay on alert, access to our social media, and keep following us for further updates. We have an upcoming training also in Uganda in August. We're going to announce this the next week, but we're going to have more opportunities to do this in following days or months. So just stay in touch. That I hope that you'll manage to find the best opportunity for you to access to these trainings. In the meantime, if you are starting for being a novice on R, I highly recommend you to also access to our colleagues and allies in this regard, which are Apply Epi, basically, which you can access more frequently to training on basic art, which is going to give you or put you in a good situation to access to these trainings and the tools that we're disseminating. So also reach Applied Epi if you are looking for solidifying your base understanding of R and increase fluency with basic art tools or introductory and generalizable tools. I mean, generally they are covering from data wrangling to exploration and basic initial descriptive analysis and also inferential analysis useful for outbreak analytics and surveillance.
Thank you, and
So,
thank you, Andre. Thank you, Joshua. Andre, were you going to say something?
No, just moving forward to Karim, I think, because we're on time. So we're now going to move to Karim to hear the second part of the session. You can keep doing the code, but please, we want you to better pay attention to Karim's talk. And then we're going to move back to a set of questions and then more general questions at the end of the session. So yeah, Karim, when you're ready.
Just one thing before Karim, thank you so much. And let us know how do you go with the How did you go with the platform? How did you go with the code? Just put it in the Q&A questions feature. Thank you. Karin, over to you.
Thank you, Diana. Thank you, Andre, and thank you everyone for joining us today. I hope that Josh has get you warmed up and ready for epidemics analytics. But before we proceed with this, let's see how you can clean your data. So this is the outline, but I'm not going to go through this because I'm assuming you guys want action today. So let's pass in. So first, we will begin by getting the data set. So what we are going to do here is we will use Simulist to simulate the data and then messify it. Here we are choosing one argument to make sure that we have some data with inconsistent date. We are setting the seed here to 1 so that everyone can have the same data set and we can compare results. Also, we will be using throughout this presentation, this notation here, package name, double column, function name. If you're not familiar with this, don't worry about it. You can ask question later, or you can continue looking about this in the internet. So this is a data set that will be having 174 rows and 13 columns. As Josh already shown, we have an ID column, case ID, case type, sex, and so on. These are typical variables that are needed for epidemics analysis. And before we begin the data cleaning, we are really interested. We want to try to understand better our data set. So in CleanEpi, we have a function called scan data. What the function does, it will go through your character columns. I'm going to repeat this again. It only works on character columns. So in case your data doesn't have any character column, you use this, it will not produce an output. Don't think the function is not working. It's just because there is no issues when a column is only numeric, is explicit, is clear. So in character columns is where you can have numerics, dates, and other types all together in the same column. So what the function will help you to do is to get the proportion of numeric date characters logical, as well as the proportion of numeric values across all these columns. And it will help you identify columns where you need some cleaning. For example, the output of its function will look like something like this, where you have the field name and 5 different columns that contain the proportion of the different data types and missing data across every of these columns. What you need to consider is the syntax name, the syntax in the column names. Sometimes the syntax is not as easy to handle with R. And also you need to consider looking into columns with multiple data types. For example, these columns highlighted here in red has a certain amount of numeric and character values in them. And what you need to consider, what you need to do is to check your data dictionary, whether this column is supposed to be a character column or it's supposed to be a numeric column. And then you can proceed with CleanEpi to perform your data cleaning. The second thing is to standardize your column names. This basically, we choose to standardize on snake case. We have a function called standardize column name. What this function will do, it will convert any other character into English character. I can imagine some of you saying already, oh, what are these people trying to do here? I don't want to convert my very nice characters written in French into English or written in Spanish into English. I want to keep them. So what the function offers is the possibility to keep what you don't want to standardize on. It means it will not do anything on those columns, but also in case you only interested in renaming a few set of columns, then you go for the rename argument and you give it your new name together associated with the old name that you have there. When you run this normally, from the beginning here, we have this set of columns with the ID, but now that ID has become case ID, the sex column has now become gender, for example. It is also very common to see in a data set where people are using missing data. Instead of using NA, they use a missing data character. So let's say in your data set, you are using not available, for example, or you are using -99 to say this is your missing data. What this function allows you to do is it allows you to convert those strings into NA. So this is what R handles easily the most, and most of R functionalities works with this very efficiently. So the function takes the 3 arguments: the data, the NA string, and the target column. So this allows you by default, if you don't provide the NA string, as I did here, I set it to null. What it does is it will look for this missing value string in your data and try to see whether any of this is available there, and then substitute it with NA. If you already know what columns you are targeting for this operation, then you can specify a vector of column names directly using the target name, the target column arguments. If you also have in your data some constant, in your data set some constant data, what we define as constant in CleanAP is empty rows, empty columns, but also constant columns. A constant column is a column where you have values where the values are the same across the whole column. For example, if all samples are from the Gambia, the country variable will only have Gambia in it. That variable is not adding any variability to the data set. Then you will not need to go through that again. So you can run this and you can use the cutoff to set the cutoff after beyond which every column that contain that percentage of missing data or constant data will be removed. What the function does is it works iteratively. It means it will keep doing this constant data removal until there is no more constant data in your data set. However, we admit that there is a limitation in this function in terms of if you want to make the filtration only on rows without doing the filtration on columns, or if you want to do the filtration on columns only, but not on the rows, the function will not be able to give you that functionality, but the Janito package can help you do such filtration. So the other important thing to consider is standardizing dates. When you have some date values like this, which is the case in this data set because we made sure to simulate it that way. So you have a mix of dates, and R does not really handle this type of values very nicely. What R actually is happy with is date values written in ISO 8601 format. So what we will do is we will try to convert this into that format. So we have a function called standardized date. The function takes the target column. So you specify what target columns you want to apply this function on. In case you only have one function, you know the format that you currently have in that, you can provide it with the format argument. And if you know what is the time frame, you know the range of date values you have in your data, you can specify with this. The Elo tolerance, I will come back to this in the next slide. And in case of data set like what we have right now with multiple date format, you can use this argument to specify what are the potential date formats you can have in those columns. So this is very important for people doing analysis in real world, because this kind of scenario happens a lot. So what we just run this first before we end up not having the results coming properly later. So by default in the package we have this order. We try to account for quarterly and partial date, as well as the orders type of date in the US format as well. So in case in your date column you have more US format than anything else, you can prioritize the US format by just making sure you change the order and make the US order to come first. So which means the values will be matched against the US formats first before they are matched with the orders. And if you have other values that are not accounted for the default, you want to add them, you can do it using the syntax here. So after running this function, normally you should get a data set that looks like this, where all date values are now in this format. As we said, this is the ISO 8601. So the error tolerance, as I promised that I'm going to explain a bit about this, is actually very important, because when you are doing the conversion of date values in a character column, if for example, there are some values that are not actually date values, they will be set to NA. Now, this argument allows you to tell what is the percentage of non-date values you are ready to allow after conversion. So if the percentage of non-date values goes beyond this, the column is returned as is. It's not going to happen. The conversion is not going to happen. Now, going forward, we have noticed that the date guesser fails in many occasions. So we decided to make sure that target column becomes mandatory. You can see the output of these functions in the report, as I will show you later. One of the important functionalities also for epidemics is trying to see whether the sequence of date events is happening in a chronological order. For example, if you want to check whether in your data of millions of rows or thousands of rows, all the rows from the date of onset, date of admission, and date of discharge is actually following the chronological order, you can use this function called check date sequence. You provide it with those target columns, then it will be able to check whether there is any rows in that data set where this order is not respected. So what the function will do also is it will return your message. For example, if I'm comparing two columns, in one column, in row 1, for example, there is a value, but then in the other column is missing, the function will not be able to perform the comparison. So what it does, it returns you a message telling you that I'm not able to make the comparison across these rows, and then across those rows, along the rows that I can make the comparison, I have not seen anything, any date sequence that is not correct. So also the time span, this can also be a very important function in epidemic, especially for people at ministry level who are trying to implement the 717. For example, you want to know whether there is any delay between when the case is spotted out and when the case is reported. You can use this function to see what is the time span between those two events. And you can use the time span function to actually do this. It takes the target column, which is one of the columns that you want to compare with the second column that comes into the end date. And you can have the possibility to also provide the name of the new column that will be generated. The nice thing is the unit can be in years, it can be in months, it can be in weeks, it can be in days. And the reminder also, you can, if the unit is in months, you can decide that I want the reminder to be in days. So after running this, normally we are supposed to get something like this. So what this is, we have the two columns that we have compared. Here is, you have some NA, so no comparison happening here. And given that we wanted the time span to be in months, nicely, there is no rows where the time span is in the time span between the first and last contact is more than is going beyond 1 month or even 1 month. Everything is in days, so we only have values in the days, reminder in days. Also, as Josh mentioned previously, these two columns, the case ID and the age, has some character values in them, and we want to convert this into numeric. We can use the convert to numeric function, and this function will take a target column. You provide it with a vector of these two columns and the language in which the characters are written in. Currently, the function support English, French, and Spanish. And after you run this, normally you are supposed to get your new set of two columns with all values being now written in numbers. This function actually heavily relies on the numberize package. So the function makes calls of the main function from the numberize package developed by our colleague here at MRC, Baki. Another important also cleaning operation is the dictionary-based cleaning. Say you have column where you have a set of values that you already know what they should be, but along the line when people were entering the data, there was some typo. So this function is very important, for example. So in the case type column, if we look into this, I'm gonna comment out this for now, and let's run. We have things like this. Instead of probable, there is a typo here. There is a typo here around confirmed as well. So what we want is to correct for such things. So we are going to construct the dictionary. Now that we have identified the possible problems, we give them the normal values. And then we use the clean using dictionary function, and this will be able to substitute all these variables to the corresponding ones. So I'm gonna rerun this, and what we will see is we will have our data dictionary that looks like this now. And after we now, let me run this below here, so we can see that at the end, our column will only have values like suspected, confirmed, probable, and some missing values, which normally is allowed for. So going forward in the next version of the package, we are currently working, especially Josh is working on a feature to make some string matching. So we will have a more lenient, a more flexible function that can allow you to build to do this dictionary-based cleaning. So there are other functions in CleanAPI that we don't have the opportunity to present here today. So given the time limit, so what I did is I put them together to show you how you can use CleanAPI in a pipeline, for example. So again, let's regenerate the data. We have already done this. I'm not going to make any comment on this. I will only comment on the function that we have not done. So what we want to do is to use the test data, standardize on column names, replace missing values, remove constant, standardize the dates. This we already have covered this. We want to remove duplicates. This takes the target column. Here we set it to null, meaning we want to check duplicates across all rows. We want to convert to numeric. We have already seen this. We want to check also the subject IDs. So in this specific case, I'm just gonna set the range value to between 1 and 100. And if I run this, normally it should tidy up everything, accounting for what I have set as parameters. And it comes out with a lot of messages, because every cleaning operation will return some message to the user, so you can know what to do, and you can also know what is going wrong in your data. And we have this function to add something to the report. I'm not going into details for this. And then we have the report printing function. This allows you to print a nice report like this. First, we see the results of the data scanning. Already we have covered this. And we see also the results of the column name standardization, where the original column name was this. It has now been changed to this. This one has also been changed to gender, for example. And we have the output from date standardization. This gives you the rows, the set of rows where you have date values that are outside of the time frame. This one gives you the opportunity to look into the set of rows where a date value can have multiple formats, for example. The incorrect date sequence here, there was nothing. So the duplicates also, you can take a look into your duplicated and those that are removed along the line. There was no constant data, so that row is empty. There is no misspelled value because I didn't report this. This was supposed to happen, but I will check this later. No missing values was replaced with NA. So the subject ID, this is something that we are working on right now, because this is not giving something accurate, but in the next version, we will have solved this issue already. And the columns that have been also converted from characters to numeric are also shown. All right, so this is what I had for you today. You can consult our repo, the Epiverse trace repo, for more documentation about other Epiverse packages. You can take a look at the CleanEpi documentation. You can raise issues as well. Thank you.
Thank you, Karim. I think this was great. Also, I think we have time for 1 or 2 questions, and then we will jump into the Post-it platform for you to try CleanEpi. So please post your questions in the Q&A. We have one question that I think either Joshua or Karim can answer. Karim, can you read the question, or should I read it? It says, thank you both for the excellent presentations. The package is very interesting and has great potential. I was wondering if you have considered developing a command line interface, allowing users to pass necessary inputs and parameters as arguments. This will make it more accessible for users who are not familiar with R. Alternatively, integrating such functionalities into the backend of the deployment dashboard could also benefit not coding users. This is from Kadim.
Thank you, Hadim. This is a nice suggestion, but what we realize also is already having R functions, and for people who are not used to R, is a bit more difficult to perform all these functionalities and perform the data cleaning. So I think one of the things that we are thinking about is to try to get, let's say, a more visually based way of handling this. So in terms of command line interface, I think that would be a bit more complicated for new R users, whilst if we have graphically a graphic interface where you can provide these different arguments for every function, I think that will attract more users towards our packages. But for command line, I think is more for advanced people than novice people who are new to R. I don't know what Josh and Andre, Diana think about this, but what we notice is people want to see more graphical interface than even the R commands.
Yeah, I mean, I would mainly echo what Karim said. I think just to add that we are very aware that there's a lot of, I mean, Epiverse is quite a broad initiative, as was shown on one of my slides. There's a lot of packages that a lot of different people are working on, and it would be great if we could implement them in different frameworks, different languages, but there's just not capacity for that. So I think we've targeted R, just with it's fairly ubiquitous amongst epidemiologists and public health professionals. So for example, not only is there Epiverse, but there have been previous initiatives like Recon. There are other teams around the UK and around the world developing R packages. And then you have teams like Applied Epi that Andre mentioned in the chat, which are also doing great work focusing on R. So this is where we really thought sort of the value add would be. But I think it's a great point around dashboards. I think some of our colleagues that were based in Bogota as part of Epiverse, they were also doing some great work on some dashboards. We've also had to play around, nothing yet out there that's fully developed, but it's definitely something we're exploring to try and, like you say, open up the market to people that are not necessarily experienced R programmers.
Thank you, Joshua and Karim. Andre, do you have any comments? Otherwise, I think we can jump into the interactive platform.
no further comments. I just want to let you know that you can access to the link to the file O2 on the POSIT cloud. I can show you that in a bit. So if you are already in the POSIT cloud, you're going to find script number 1 that is about Simulist, and script number 2 that is about CleanEpi. So just take your time to explore this code. And in the meantime, if you have any further questions, just let us know. Okay, I think that now I'm in good position to share. But just emphasizing that we expect you to be in the script number 2. And well, one difference with the other code is that if you are not familiar with these code chunks, you can run each of these with a play button in that upper right corner of each of these sections that are called chunks in this type of file. So now we are open for more questions. I don't know, Karin, if you would like to handle more questions from the chat, or if there is no.
Are there any further questions, comments? Would you like to tell us a little bit? What functions did you find most practical for your work, for your for your work? Or are there any other functions that you would like to see? Maybe we can tell you what packages you can use.
So there's a question on training, which I guess I'll hand over to Andre. So just to read out from Boris, will the training in Uganda involve hands-on experience with the current packages, or have you got other plans?
Yeah, thank you. Yes, I now can see the Q&A. So yes, the in-person trainings involve hands-on experience in a step by step, following our tutorials, and also having additional challenges and having some assessments in the middle, and working in groups. So that's the experience that we're trying to give, either for in-person and also online trainings. And I think that that's what I can say about these trainings. And as I mentioned before, possibly taking advantage of this question is that the materials are freely accessible, so you can also work on them self-paced if you find it appropriate, as we answered before. So thank you, Boris, for your question. If you have any other question, just let us know.
Just a reminder, we will be sharing all the resources, including the recording, including links to access CleanEpi, Similis, all the resources we have, so you can take a look and you can explore a little bit further, because this is kind of like a short time to explore all the functionalities of the packages, but we will be sharing everything. You can also find that in the Epiverse website. I think, Karim, this is questions for you.
So there's one question come in, I can see at the bottom about some code that's not working. So the question, I'm getting an error using the function create prob distribution. So if you try that, so that is a function from the epiparameter R package. So if you just make sure you have epiparameter installed, make sure you have the latest version. So to do that, you would do install.packages epiparameter, and I'll paste all of this onto the chat just so you have you can copy it over if you want to. And then just make sure you're loading the epiparameter package. So that's using library epiparameter. And then if you try again, it should be able to find that function. So that's basically an issue with R not being able to find the function. So if you load the package, hopefully that'll be resolved. I'll post an answer also in the chat.
Possibly we can show that really quick if we still have time, because I found that function on the RStudio Cloud. If I think that the question was about this, yeah, actually if you want this function to run, then yes, run this line of code, and then you're going to be able to run this other function, which is going to help running all of this.
I think, Andre, there is another question about whether we have a book about Epiverse packages and how they can learn practical approaches about how to use the packages. I think you can talk about the how-tos.
Yeah, for sure. Yeah. Thank you, Karim, for reading the question. How to better show this? I think that well, I think that given the time, we can use the same links that we shared above. So we have, let's say, documentations for learning and documentations for using in during the work, let's say. So as we shared before, we have tutorials, and these tutorials are free to access and to follow on your own pace, which is the best book-like material to start learning this about these packages connected with a curricula based on the main topics or questions that we are able to cover. If you are interested more in, let's say, specific questions that are more connected or related with some people with more expertise, you can access a new type of documentation that is called the how-to guides. That is like a recipe-like of code scripts, which is something that we're going to be improving in the following weeks, but I can share a link about it. So yes, wait some seconds, and I'm going to be sharing the links in the specific question. Thanks for
Well, I think we're coming to the end of this session. Please let us know, what do you think about this session? What can we improve? Is there something that you would like to see in future hands-on webinars? Thank you so much for attending. This was really interesting for us to explore new ways of engaging our community and involving you in the practice and operationality of Epiverse. If there are not further questions, I think we can, yes, there is another question. We will send you all the resources, recordings, links with access to Clean Epi, Similis, Epiverse that Andre has been sharing along the webinar. And we will also send you some manuscripts of how, where Epiverse have been featured with a practical approach of the packages. We can share all that also. Thank you so much, Andre, Joshua, and Karim, for helping us in this webinar, and we'll see you next time.
Thanks everyone for attending.
Bye.